Hey folks, sorry I couldn't be here Monday. No one to watch the kiddo, so you guys get to see me on TV, no big deal. Here I am. Alright, so hopefully you guys got in the warm-up. You remember the whole scale factor idea, shrinking, enlarging. We should be pretty good at the cross multiplying thing now. So we're actually going to perform this and kind of get into how a computer works. We'll even talk a little bit about animation. So let's say we actually want to perform a dilation. Instead of giving you a smaller triangle and a bigger triangle, now we're actually going to perform this act. All right? The idea of shrinking or enlarging something is called a dilation. Just like when you go to the eye doctor and they dilate your eyes, what they're doing is they're enlarging your pupil so they can look into it. So they're enlarging that space. So we have the scale factor idea, and it seems like a pretty simple concept. Let's say our scale factor is 2. Or maybe it's 1/2, depending on the direction we're heading. So if I wanted to double the size of this, I could just figure out how long this was and then multiply by 2, right? Figure out how long this is, multiply by 2, figure out how long this is, and multiply by 2. Simple enough concept, right? So let's say I did that, hypothetically, maybe this is 10, so I draw a distance of 20, and I do it on the bottom, and I do it on the side. And I've doubled this triangle. Really simple, right? Well, here's the problem. The problem is orientation. We've doubled this triangle in size, fine. Or maybe we started with the green one and we wound up with the black triangle. But either way, half or doubled, where is the triangle supposed to go? Fine, we've performed a dilation of 2, scale factor of times 2. It's double the size. But who's to say that the triangle doesn't go over there? Or who's to say the triangle isn't here, or anywhere in two-dimensional space? So the trouble is orientation. A proper dilation is not just enlarged or shrunk by a scale factor, but it also has a very specific orientation to one central point in space. And that central point in space is, probably should turn the marker on, it's called the center. It's the center of the dilation. If I'm going to shrink this and make it half its size, or if I'm going to double it by twice its size, I have to do it from a specific point. Which means, if I were to shrink this, I'd be zooming in towards this point. It's a reference point, just like when you guys grab your iPhones, you take your picture, you click on the corner and you drag it smaller or drag it bigger, you're doing it from that point of reference, and you're zooming in towards the opposing corner, or towards the upper right, or wherever you click and drag, there's a central point that you're zooming in towards or zooming in away from. The same rule applies with all dilations. So if I were to double this triangle from this point, this triangle would actually have to exist somewhere over here. Now I'm just eyeballing it, but where exactly would it be? Well, then we need something called a guideline. If we were to do this by hand, I actually don't care at all how long this line is, or this line is. What I actually care about is how long this line is. I've zoomed out from this central location this far. If I want this triangle to be twice as big, then I need to zoom out twice as far, and I need to double this distance. Now I'm just completely eyeballing this, but that will automatically double the size of every other distance in this triangle. And I completely winged this and didn't measure anything, but I'll know I'm close because these should all line up, and this distance should have been double, so my estimation was off, and these should fall straight in line, and I'm slightly off here, and this distance should have been doubled here. And I never needed to measure the green triangle. I never needed to measure the black triangle. If these distances have been doubled, then this will automatically be twice the size. So this is how you perform a by-hand dilation. Now, if I were there, I'd have you guys actually bring out a ruler and do this, but I don't think it's necessary in this case. I just want you guys to get the concept. So imagine we took this triangle, and I wanted to double it in size. Well, I can't just randomly double it and throw this triangle anywhere I want. I need a point of reference. Here it is. Here is the center of my dilation. So what would I do? I would measure this distance right here, and then I would double that distance. So again, I'm going to do a hypothetical here, but imagine I measure this distance, and maybe this is 2 feet. So if I wanted to double this triangle size, I'd want to be 4 feet from this center location, or another 2 feet from this point. So I would venture off into the distance, and I'm just trying to eyeball that same amount of space, maybe somewhere up here. And of course I would do this 2 more times. I'm never measuring the black triangle. I'm measuring the distance from the center of the dilation. My scale factor is 2, so every distance is being doubled. If it was a half, well then I'd divide this distance by 2. Or technically we'd be multiplying by half, wouldn't we? So I'd do this again, and that distance, maybe that's a foot. So I would double that distance, and maybe I'm here. Again, I'm just estimating. And then this one, I'm going to need more room on my board, aren't I? So this guideline would travel all the way to that point. So doubling that distance is going to take me way down into the corner of the board somewhere. Maybe I went far enough, maybe I didn't. And hopefully, completely winging this, I don't have a meter stick or any measurement tool, but hopefully this is pretty close. And we jump all the way down and all the way up. And does that look like it's been doubled in size? I think it's pretty close. We just gotta eyeball this. Looks like it's about half. I feel really good about my estimate here, and that's no measurement at all. So the concept of a dilation is the distance from a center point. Using that measurement, the dilation will automatically occur. This green triangle will automatically be double this triangle because we've doubled the distance from the center. And the only thing you actually measure are these guidelines. That's all we needed to measure. And now this job gets even easier. So I'm going to ask the sub to pause the video for a second. I need you guys to grab a scratch sheet of graph paper, and on the top of it, please write scratch sheet, because you're going to use this over and over and over just to do some quick sketches in class before we get to the nitty-gritty. So give it a quick pause, and everybody grab a scratch sheet of graph paper from the front, and then we'll come back. All right? Did we pause? Are we back? Pause? No? Yeah? All right, I'm gonna go on. So I want you guys to graph this on a sheet, on one of your empty graphs, triangle JKP. And now we're gonna perform a dilation on an XY axis. And you're gonna find that your job now has gotten much, much easier. And as you graph it, I will also graph it. 2, 4. There's J, 4, 4, there's K, and 3, 2, there's P. There is triangle JKP, and notice a second vital piece of information that we are given is not just the location of the triangle. We are told we are centered at the origin. So I know I'm zooming out from here. All of the dilations you perform in this class that are not extra credit will be from the origin. Keep it simple, yeah? Let's keep it very simple. And now we're going to dilate. We need one more piece of information. Here's the triangle. We're centered at 0, 0. Oh, that's right. We need the scale factor. This is the most important piece of information in a dilation. How much bigger or how much smaller are we getting? So what are we doing with a scale factor of 2? Well, we're taking this distance here, this distance right there. So let's say I was moving J. This is the concept behind a dilation. To get to J, I moved up 4 and over 2. So I'm going to double that movement. A scale factor of 2 would double that movement. So I've gone up 4 over 2. And this point is called J prime. This is the new location of point J. J prime tells us that all we did is stretch out this location. This is not a random location in space, but a dilated location in space. Some sort of transformation has been performed. J used to be here, and now it's here. And now we can do the exact same thing. I'll draw my guideline doubled with K and P. So to get to K, go away, stop it. Go away, go away. Nah, fine, now it's gone. Looks like we're going up 2 over 3. So we'll go up 2 over 3 again. And that'll be P prime there. And then K is up 4 over 4. So we're going to go up 4 again and over 4 again. And there is our new point. And this should be a perfectly doubled triangle. And it sure looks like it's twice the size, doesn't it? It's got to be a shortcut to this, right? We shouldn't have to draw all these guidelines every single time. Well, on an XY axis, you don't. You don't have to measure anything. Look at how these coordinates turned out. It's very easy to see the shortcut. Watch how fantastic this is. Here are my original coordinates. What did J prime turn out to be? What's J prime's new coordinate? Well, we're over 4 and we're up 8. Over 4 and up 8. Well, what happened with this coordinate? Of course what happened? 2, 4 became 4, 8. Why? Because the scale factor was 2. On an XY axis, the grid is perfectly symmetrical. And since our center point is always starting at nothing, then naturally the movement, the coordinate itself tells you, I've moved this far over and this far up. And if the scale factor is 2, you're doubling that movement. From 0, 0, every single time it will just double this coordinate. Well, now your job is incredibly easy. All you have to do is multiply these numbers by the scale factor and you have your new coordinates. And done. You performed a dilation. So if our scale factor was 1/2, I'd multiply this by 1/2 and I'd get 1, 2. And I'd get 2, 2. And I'd get 3/2 and 1. And I could graph that no problem. Any scale factor, I'm just going to multiply. If it's on the XY axis, and if we're centered at 0, 0, all I have to do is multiply. If we're not centered at 0, 0, things get a lot more complicated. So let's finish this. I'm not even going to look at the graph. Scale factor is 2, so K, is everybody K? K. K prime is going to be 8, 8, and then P prime, I'm not even going to look at the graph. Doubling that gives me 6, 4, and those match up perfectly. All we would need to do is multiply these by 2, and we could go back and graph later. You don't even need to understand the concept anymore, because it's a shortcut. Multiply by 2. So you can take this, multiply by 2, multiply by 2, multiply by 2, and we are finished. But we're not finished. I did tell you guys these things were going to come back. We have to know how to use a matrix. Why do we have to know how to use a matrix? And those of you that are going to be coders one day, we have to be able to communicate to a computer. Here's a triangle, and we want to do this to the triangle. The computer has no idea what a triangle is. You have to teach the computer what a triangle is. And the computer has no idea what a scale factor is. You have to teach the computer that too. So this is very, very simple. You can write your matrix horizontally or vertically when you're doing a dilation. It does not matter. I'm going to go horizontal. I'm going to put all of my original coordinates into a matrix. So 2x, 4y, 4x, 4y, and 3x, 2y. This is my original image matrix. What did I do to this matrix? Well, whatever I did to it, I need to produce these 3 coordinates. So I program this into the computer, and I say, hey, computer, double all of that. And then the computer will spit out the exact triangle we are looking for. I know we're going to get all these coordinates. Every number is going to double. And this is what it would look like as a matrix. If I said perform a dilation with a scale factor of 2 using a matrix, you would put all of your original coordinates into a matrix, you'd multiply by 2, and then you'd write down your new coordinates. That's as simple as it is. This is what a dilation looks like on a graph. Nothing to it. Make sense? Pretty simple? Hopefully. Hopefully it's not too bad, yeah? Alright, so what are you guys going to do? Well, your task will be this. Each of the next 4 days, you guys will be given a portfolio task. You're going to receive a 4-page stapled packet that has day 1, 2, 3, 4. Obviously today's day 1, called dilations. And your requirement is to finish the first 6. Every day you're required to finish the first 6 as part of your portfolio grade. The graphs are numbered 1 through 8, however. Number 7 and number 8 will always be a bonus point. There will be 2 every single day. You could earn 8 bonus points on your portfolio, but these are not super easy. Why not? Because you guys will notice, centered at the origin, 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 and then number 7, I center you somewhere else. And now you have to understand the concept. The concept of this distance away and doubling, or in this case, halving. Same thing with number 8, this one is centered at a different location. So you have to be very, very careful. All right, take it easy on number 4, it can be a real beast. Because, tough crowd, tough crowd. 5 should be a lot of fun though. I think 5 is going to be a lot of fun. So what are you doing on your portfolios? You guys are doing this. This is your expectation. You guys need to graph the original shape. You can graph it in pencil and pen, whatever you guys have. Please label it A, B, C. And then if the problem itself says, hey, perform a scale factor of 1/2, you will then also graph your new shape that is half the size. So you'll notice this coordinate is over 1 up 4. So I multiplied those by 1/2, and now I'm over 1/2 and up 2. And that became B prime. You don't need to write down any coordinates. You don't have to write down any of your math. All I need to see on your portfolio is the original shape labeled A, B, C, and then your new image labeled A prime, B prime, C prime. Please do it in a different color. I've got colored pencils and markers over on my shelves. Over on the side, you guys know where all that stuff is. So please do it in a different color. That is the only thing that needs to be in your portfolio. All right, this is not one of the problems, by the way. This is just a random problem. So this is your task during class. If you guys need help, please ask. The sub is mathematically savvy, so she can help you for sure. And then once you guys are finished with this, everybody has to get through number 6. If you have time, then you might as well try number 7 and number 8. Why not, right? No? All right, that's it. When you guys are finished with this, this is your homework, and I will see you on Tuesday. Hopefully, I plan on being there Monday, but I plan on being there Tuesday for sure. All right, that's it. See you guys in a day. Have a good one.